All right. In the interest of time, I think we're going to get started. We have 5 lightning talks. We're going to keep them to about 5 minutes apiece, and at the end have a open kind of panel session questionnaire. So hold your questions till the end, and we'll have all the presenters up there. But we'll start the timer now. Bill, it's your turn.
All right. Hello, everyone. So, my name is Bill DeRusha. I am an engineering manager at edX. Feel free to contact me through any of these channels. But for right now, given that we have 5 minutes, let's talk about digital credentials. So we're going to go through what Open edX has today for digital credentials, the things that edX and our team is building for tomorrow, and then the things that we can do to help build the future of credentials for Open edX at large. So what is a digital credential? That's probably a good place to start. It's a proof of qualification, competence, or clearance that's attached to an individual, and it proves something about the owner. Now, that's great, but without any context, it's not very important. So why is having a credential important? I think the important thing to take away is that credentials aren't the end, they're the beginning for the learner. The learner takes this course, and often we think about that as being the end of the road, because they finish the course, you give them the credential, and they're done. But they're just starting. They are taking that credential, and they're bringing it to an institution to say, hey, I know this, I want to do more of this. They're bringing it to an employer saying, hey, I know this, I have this skill, let me do this skill over and over and over again for you. This is the beginning of the road for them, and the more useful we can make the digital credentials, the more flexible, the more places they can take it and have it be interpreted in the right way, the better that is for learner outcomes. So today on edX, we have a couple of digital offerings. There's program certificates and course certificates. Most people are aware of these. There's been some great talks today that have incorporated the open badges work that's available on Open edX for micro-credentials and smaller skills. But we're already starting to move the ball forward. So the things that my team is working on at edX right now is student records. You heard Marco talk about that in the plenary session a little bit. Once a student has completed a section of courses, a program, they receive a student record, which is kind of like a university transcript, although we're keeping the two things separate so that they don't get conflated together too much. And the idea is that a learner can then take that student record and use it for university credit pathways, use it for employment pathways, use it in ways that we aren't able to define for them, and let them explore what a digital credential can mean for them and not limiting them. So this, can you see that? Yeah, great. So this is some wireframes of what we're planning on landing. It definitely won't make it into Hawthorne, but it will certainly be in Ironwood. And it's basically just a list. It's a little bit more depth compared to your traditional certificate. So it has some great information. It has how many attempts they took in a verified mode. It has their highest grade. And you can imagine in the future adding even more depth to this, where you link in course syllabi so that people can see, oh, not only did you take this course, but what was in this course. You could link micro-credentials that make up the final credential that make up your whole record. There's a lot of pathways here. We're building credit pathways in our V1, so you'll be able to take an edX credential and apply to an on-campus master's program. And then we're also offering the students the ability to share this more broadly with employers and others in ways that we're not predefining. We're just making, letting users opt in to having a link that they can share with whoever they want. So the future, what's beyond, and what can we all do to get there? So the XAPI, we've heard a little bit about that if you've been to some of these sessions. Open Badges has a V2 out since 2017. Block certs, blockchain, distributed verification, all of these things are things that help learners use their credentials in more places, which makes it more effective for them and for their outcomes. And I think there are a lot of things we can do to help get there together. Course certificates that live in the LMS, if we move that data into the Credentials app and have one application that owns all of your credentials as a learner, I think that opens a lot of doors for future work. Adding a course level record, not just program records, is on a roadmap. And having certificate configuration improvements. There's a lot of work to be done to make open edX credentials better and easier to use and easier for learners. And I'm happy to talk about it with anyone after. And that's my time. Thank you.
Hi, everyone. My name is Luiz. Oops, I think I passed. My name is Luiz. I work for IBM. And here I'm just going to talk about the project that we have on having certificates into blockchain. So it's a nice segue from the Bill's presentation before. So before I begin, a little bit of what I'm not going to talk about here. So a lot of people heard blockchain and think about Bitcoin and pricing and ICOs and stuff. I'm not going to talk about any of those. No weird expressions and mining. So let's just get it off the table. But there's nothing bad about those things. It's just that it's not their interest that I have in blockchains. What I do find interesting is that behind all of this, there's a data structure that is very interesting. So just to level up a bit the knowledge around everyone, what a blockchain is, essentially is you gather a bunch of data into a thing called block, and you link them together with the previous block using a cryptographic hash. So you're basically attaching a fingerprint from the previous data that you had into the next one. So that's what's called blockchain. And another thing that is important is the consensus algorithm. So a blockchain is a network of several nodes, and they are all calculating these blocks, and eventually they're going to come up in agreement, even without trusting them. So that's in a blockchain like 30 seconds. I don't have time to go in deeper, but that's the overall information. What does those things give us that is very important? So cryptographic link gives us immutability. So it's very hard for you to go back in history and rewrite something because you have to rewrite the whole chain. So you need to compute all the hashes and the links before that. So it gives you a nice safety net of you know nobody's messing with the data from the back. The consensus algorithm to give us trust, even when you don't necessarily trust other parties. There are different algorithms that give you that. So mining is just one of them. But this essentially gives you a set of entities can collaborate together without necessarily trusting them. So trust is embedded into the system. There's several types of blockchain. The most famous ones are the public permission one, like Bitcoin and Ethereum. What that means is that anyone can read and anyone can participate. They just need a node. But there are also other types. So there's public permission, where anyone can see the data, can read the data from the blockchain, but only a few people can actually put blocks into the chain. So only a few people can write in the chain. And there are private permission. So there are chains where only certain participants can read and write to the chain. Often, so on the permission column, there's often a consortium of several entities collaborating. In theory, you can have a private permissionless chain, but it doesn't make sense. It's like anyone can write, but only somebody can read. I cannot think of a use case for that, but in theory, it's possible. So that's all I had to talk about blockchain very quickly. And what we're doing at IBM and Cognitive Class, we're launching a project called Documentorum. And the idea here is that to store students' accreditations, documents, and certificates into a blockchain. So that will give us one, you decentralize the storage of the certificates. So right now, edX certificates are stored on edX servers. MIT certificates are stored in MIT records, stuff like that. If anything happens to these institutions, the certificate is gone, and the student just have no record of that. If you decentralize storage, you can keep it more permanent. And you also allow for multiple entities to collaborate. So for example, once you start involving the government can vouch for a certain institution. And this can all be through the blockchain, so anyone can verify that it's actually a valid document. I think I'm out of time. So, okay. But that's basically it. I don't think I have more to talk. Just thank you, and A quick marketing plug here. IBM just launched a course on edX.org. It's not about blockchain, it's about chatbots, but check it out. Thank you.
Hello everyone. My name is Mehdi. As you can see with my shirt, I'm one of the fun guys. I work with France Université Numérique. Sorry, I was clicking. And today I'm going to talk about one project we recently launched, which is CMS for OpenEDX. So let me clear something up. This has nothing to do with the CMS in OpenEDX, the studio. It's an entirely separate project, like a publishing platform. So I'm going to talk about why we're doing this and what we're doing. Then I'm going to show you some things we've already done, and then say what we are planning and doing in the future. So, what do we want to put in this CMS? There's basically everything we at Fun think should not be in the LMS itself. So that's the course catalog, the syllabi, the subjects, organizations, and teachers. And each of these has a page in our CMS, and so it can be pretty useful for SEO and stuff like that, because those are long-lived pages where you can find the links to the courses, of course, but they stay and you can optimize them and have your marketing people change them to better market the course or make it more discoverable or things like that. So what do we plan on doing right and doing in with this? We want it to be multilingual by default. That's why we picked Django CMS as a tool. So everything, including the interfaces, but also the content itself, such as the syllabi and things like that, everything is translatable. It's multilingual by default. We don't have to add this on later. It's baked in. Also, we want to build a great search experience to enable learners to easily find courses through means they might be used to, like an auto-suggestion search engine and things like that. And finally, we're using the same tools edX is using, like Django, React, Bootstraps, all of this. So now I'm going to show you what we have today. Basically, it's just a search interface for now for courses. So that's what it looks like. It's pretty simple, really. You have a list of courses, filters on the left, and a search field on the top. So let's say I want to do computer science. So sorry, the search is in French. It's informatique in French. So I start to type it out, and then I have suggestions for courses that match. If I click on one of the courses, I can be taken straight to the course page in the CMS with the syllabi, and then go on and enroll in this course. But maybe I want to see more courses in computer science, so I can click on a subject, and then it adds the subject to my filters on the right. And as you can see, I can add several different subject filters, also several different institution filters if you have several organizations publishing on your platform. So basically, that's the way to make the most of a search to find courses any way the learner wishes. So what's next? Well, you can see it's pretty rudimentary for now, but we want to share this with the community, so we want to enable theming. For this, we are favoring using the same approaches that the edX teams themselves are using, so Bootstrap themes, and for React, maybe the React Context API, but I don't know, we mostly want to hear from you and also do what the edX people are doing on this front. Then we want to improve search. Right now we can't search in the syllabi themselves, but that's something we plan on adding very soon. Also search courses by teachers, so if you like the course by a teacher, you can find more. Maybe even index the full course content, so as to maybe enable serendipity in course discovery, but that's further out. And one more thing is this can have multiple backends, such as several OpenEDX instances, and also maybe other types of LMSs. And for now, we only can fetch from, we only can synchronize and work with OpenEDXs, but we can very easily add more types of backends, so users can find courses across multiple instances, and also on their user page, they can see the courses where they are enrolled on all of these instances. So that's it for Richie. Today you can find it in OpenFun. Of course, it's open source and meet license on our OpenFun page. And later on, we intend to make it community driven. So we want to create something called an organization called Friends of OpenEdX, maybe, so we can develop this together and have a community stewardship for this project and other projects we're doing at Fun. Thank you very much.
Hello, everyone. My name is David Truong. I work with Pierre Mailhot over there and Cédric Joyal, our web designer. So as I work for edulib, the open edX instance of the University of Montreal and Polytechnique and HEC, so our host. Have you guys been enjoying Montreal? Okay, so we've been led to develop our own course portal using course discovery. We've, up till now, have been using the OpenEDX course page to index our course and present them to our users. And eventually, we wanted to customize it, and we ran into a few problems, including performance. We had more needs, and we wanted to further customize what we already had. So, our needs: better performance, private partner pages that are not readily available from the current index, and we wanted to be able to customize the look and feel of the index page. So that led us to start prototyping and first off testing what course discovery could do. So we've learned how to use the API, how to use the publisher app to create courses. And we also had to learn how to set up course discovery properly to interface with our OpenEDX instance. So we've come to push our courses from publisher to the course metadata database in course discovery, and then retrieve it through the API. So all that is in the course discovery. And after we've been able to retrieve the data, we started using a Django app to present it. So we're still very early in our development. It's a prototype. We use the Django app, so that means learning using Django, Python, HTML, CSS, and MySQL. So we went really simple for our first prototype. We went with HTML templates to have our first edulib portal. So this is what we have right now. We reproduce essentially what is happening on the current index page for our first prototype, see what could be done, how performance was improved. And right now we're pretty happy where we are. We're going to keep on developing, and we've been talking to the people at FUN, France Université Numérique, and we'll see what comes from that. And if you guys want to talk later, here are my contacts, and you can find me on Slack. Thank you.
Hi everyone. So the talk is about Slack for OpenEdX. We're using Rocket Chat as an alternative to discussion groups. I'm going to skip that. So why OpenEdX discussion groups needs to be improved right now? Because we know. Well, at least for Perversity, we want to be more collaborative learning. It needs to be more experiential. You need to have an experience when you interact with other people, when you discuss stuff, and it needs to be able to be asynchronously. What makes a good instant messenger for OpenEdX? It needs to be open source. It needs to have video and audio call capabilities. It needs to have channels, an API to interact with it, and it to be platform agnostic so we can put it on the LMS, on the mobile apps, whatever we want. What's our answer? It's using Rocket Chat with their functions and capabilities, which are you can have channels and private messages like Slack. You can have file sharing, which is very important for clients sometimes. There's no way to upload files and discussion groups properly. Send images and GIFs because everyone wants GIFs, and hashtagging someone. What do we develop? We developed a Rocket Chat Xplug. It's on our repos. You can check it out, clone it, use it. And right now, basically how it works is when you install the Rocket Xplug, you create channels on Studio, and then you specify the channel to that Xplug instance, let's call it. So you can have multiple instances of the Rocket Chat Xplug on different parts of the course, specifying the same channel, and then you can talk with everyone that it's on that course. It gives you all the functionality of Rocket Chat right now, except the video and call capabilities, which we plan to extend. And also in the future is not using the Rocket Chat Xplug, but using this new architecture about using plugins and actually just plug it in and take out the discussion groups and using just Rocket Chat or whatever we want. And that's it.
So that was our last lightning talk, which is amazing. I don't know what fear people have of going to the actual 5 minutes, but we didn't use all of it. So I'd like to invite the presenters up to take questions for the next 10 or 20 minutes or so. So, does anyone have a question?
The idea is to have a consortium of several institutions. So it's not an IPM project, it's a consortium of several organizations. So it's a permission blockchain, so we need to grant you access to the initiative, but like as long as you're not a diploma me or some weird underground company, we'd be welcome to have anyone join. And then you'll be able to access and issue certificates on the blockchain. Yeah, universities, companies that do learning in general. So it's all sorts of business. We had a pilot in Ukraine. My boss can talk more about it. We actually going to have another session later today that we're going to talk a little more about it. But we launched a pilot in Ukraine. We issue like 200, 300 certificates, 425 on our blockchain. So it's still early in development, but we have some out there.
Okay, thank you. Anybody have the next question?
I've been interested in the idea of like a live video chat as a sort of block in an edX or online learning. And I guess it's not exactly what your integration is trying to do, but is it feasible to do live video?
I mean, yes, because Rocket Chat already supports that. It's just tackling the API. It just is the first version just to have something. but I mean, you can just clone it and extend the Xplug if you want to. It's open source.
Okay.
I don't know, but yeah, it's possible.
Thanks.
Any other questions?
Thank you. Also for no, you also. Does your plugin disable the discussion function in OpenEDX? No.
No,
Okay.
no. It's something extra
Okay.
that you can use.
Okay. Thank you.
Any other questions? All right. Thank you all.
Testing. Maybe we'll just give everyone a minute to trickle in. Good afternoon, everyone. I'd like to welcome you all to our fourth breakout session today. We're here with Zach Pardos from UC Berkeley. Zach will be talking to us about collaborative-based personalization on campus and online. Welcome, Zach.
All right, there we go. Microphone's working. Okay, so I'm going to relate this talk first to our plenary talks on Wednesday, and two quotes or paraphrases in particular. One was that all courses should leverage AI or adaptivity of some sort by 2022. This was one of the bold challenges posed by the edX leader. And then another question posed, which was a challenge to perhaps all educators in higher ed, is where's the learning, right? Are MOOCs providing learning? Is it just credentialing? What are we doing to democratize success and not just access? And I think this talk, to some degree, addresses both, in that this is an example of leveraging AI and adaptivity right now. Using data, it was deployed in a course, and it's being deployed in 2 other courses. And in terms of where's the learning, this approach to adaptive personalization is in the service of making success more accessible. Right? There's been a lot of work put into making the courses technically accessible. But if you are a learner with a different background than necessarily the course was designed for, success is not necessarily within reach, even if the courseware is accessible. So adaptivity can be a way of bringing success to more learners. So the first part of this talk is on data-driven syllabus adaptation. The idea that the instructor has crafted a particular order to the course materials, and thus the pages, the verticals in the course. And that I contend that through the data collected at scale in a course, we can adapt the syllabus to different learners. So the question I pose here is, does one size fit all? Does one course sequence work for everybody? Now, on campus, maybe. If you've taught the course for 20 years and you know your students very well, it's kind of the same demographic that you're used to every single year, maybe you've fine-tuned the course enough that it's as ideal as it can be for 95% of the students that show up in your on-campus class, right? Barely plausible that that is true. What about that course on all campuses, right? For all, same major, let's say, undergrads in the same year, but would that course be appropriate on all campuses? What about for high schoolers? What about for master's degree holders? What about for employees looking at the course in order for their onboarding? So you see where I'm going here. For all MOOC learners, will a course necessarily be ideal? Probably not. The instructors know how to teach to the students they've been teaching to, and that's who it's designed for. But MOOCs, of course, are open to all. So how can we improve things? I'd say adaptation is needed. So instead of just having a single course syllabus design, have an adapted syllabus design based on data adapted to each learner. So it's personalization because it's adapted to each learner, and it's adaptation because it's a change in the experience of the course based on data. You can have that adaptation without personalization by changing the course for everyone based on data, but this would be personalized adaptation. So the way I like to think of data and AI in this case is as a kind of translation between the expert teacher's model of how of the domain of the course that he or she is teaching, and the novice learners. So it's a expert blind spot is a known phenomenon, as are other examples of the instructor having a different idea of the concepts that are learned and when they're learned from the actual learner, right? And so there's this divide. Now, again, if you have taught many, many times and your learners are always the same, maybe you've adjusted, you've tuned yourself well enough so that your model aligns very well with the novice learner model. But you wouldn't expect it to align with the MOOC user landscape. So how can we use data here? Novice learners using MOOCs create event log data. That event log data can be mined for patterns that inform an AI model that, so for the next offering of the course, can benefit the next cohort of students who use it. So examples of this might be learners who are far more advanced than the course was necessarily designed for may be able to skip material. Right? Also, learners that are significantly behind what the expected prerequisites might be, or even learners who are not ideally engaged may need to review more than the course expects, than the courseware would suggest. So what's the right model for this job of adapting the syllabus? The talk's called collaborative-based personalization. Collaborative-based methods have been most notably used in e-commerce. You've seen them in Amazon and Netflix. Mostly used based on this idea that you have a matrix of, let's say, movies by users, and through the training of this model, they learn features of the users and features of the movies, such that when a movie is multiplied with a user, it equals the rating that's predicted to be given by the user. Now, there are a couple, in the case of Amazon, this is user by items that have been purchased. There are a couple problems in just applying this standard e-commerce model to learning contexts. One is the temporal aspect of learning is pretty important. Students are building on concepts, courses are building on concepts. If you say something like, oh, you liked the first 2 pages of this course, most people who like the first 2 pages also like the chapter 9 page. Here you go. Something wrong with that, right? Also, we don't have explicit ratings for course pages. So that approach also doesn't work in that case. And furthermore, we, meaning instructors, we being the enterprise trying to create better learning online, are not trying to serve up to students pages that they're most likely to rate highly. We would like all the pages to be high quality, but that's not our objective, is you'll probably rate this page highly. No, there's a greater overarching goal of the learner that we assume in these efforts to try to improve their learning. So we use a recurrent neural network model to capture temporal course navigational patterns, and only amongst the successful learners. So we filter out the people who drop. So what is this model trying to do? What the model does is it looks at the student's previous course history up till this point. It looks to see where they've been and how long they've spent at each resource. And then it tries to predict ahead what resource they're most likely to go to next. Now, this, you could say, this is a model of what a student is, perhaps a learner is trying to do or wants to do, and helps them get there faster. But in order to help them get there faster, we need to do better than this. Because if you look at what learners do, they often get to a page, they're confused, and then they kind of page back through the course, looking for that missing piece of information. So if you just predict and suggest to them to do what they were going to do next, what they were going to do next is switch back to a page that they weren't going to spend any time on. So you want to do 2 things. You want to predict what they're going to do next and how long they're going to spend on that next thing, and predict ahead to the thing that they're going to spend significant amount of time on and send them directly there instead of having to search. Okay? So we predict ahead, we find a resource that they're going to spend 3 minutes on in this example, and then we suggest that resource. And this will be, instead of reordering the syllabus, overriding the instructor's order of the syllabus, we're going to insert a recommendation at the bottom of every page. Okay? So it's sort of like a GPS rather than putting the car on full auto. Okay? And the hypothesis is this may decrease learners' feeling of being lost and increase navigational efficiency, specifically efficiency. So here's the checklist of what needs to be done in order, what we did to enable this. We trained the model on a previous offering of the course. We reconciled any changes there were to the previous offering and the current deployment offering. So if a vertical was added, we needed to take note of that. If a vertical was removed, we needed to make sure the model never suggested a deleted vertical, right? And then we enabled real-time event logging because that's required for step-by-step recommendation. But of course, edX doesn't provide yet real-time event logs. They provide daily event logs, and a lot can be done with that, but not real-time. So we have a JavaScript snippet that we insert into every page that reports back anonymized event log data. So we do have access to real-time data. And then we enable the recommendation by inserting HTML code with JavaScript at the bottom, so an AJAX request can be made to load in that recommendation. And then finally, we stand up a back-end service, which is the recommender that services these AJAX requests. Okay, so here's what it looks like. This is in our DelfDex partner course page. This is aeronautics engineering. And this is what we've inserted into the course. It's otherwise the same as it was before, but we have now this thing that says suggestion for you. Consider visiting Lecture 1, Introduction and Ballooning, Lecture 1B, History of Flight. And here's a video. All right, so this learner's following our suggestion, which in this case sends her to the next vertical, which is a video. But she doesn't watch the video, spends no time on that. Goes to the lecture check quiz after the video, scrolls through it, doesn't know the answer to the question, is suggested to go back to the video since she didn't spend any time on it, and now she decides to watch it. So this is an example of, through a collaborative-based recommender, it detecting, well, people who didn't watch the video and didn't answer a quiz question tended to go back to the video. Why don't you try that? So what's happening in the back end here? The edX site is hit by the browser, sends back a report to our server logging that the student's at quiz page 4. It then requests from our web service the next recommendation that should be made. The web service responds, recommend video 1, and then that is rendered at the bottom of the edX page before it's done loading. Student follows the recommendation to video 1. It logs that the student's at video 1, asks for another recommendation. It recommends quiz 4. Student doesn't go to quiz 4, goes to a text page 3. Recommender is asked what to do next. It says recommend quiz 4 again, and it inserts that recommendation. And details are linked in the description of this talk. So this was an engineering proof of concept. We actually deployed this. It ran. But what works and for whom? I don't know. Let's find out. There are a number of course designers and course support teams in here. I think we need more than me and another team in order to answer this question, for whom? Right? Does it work for people with the same degree as the course is about? Does it work for employees in a particular industry? Does it work for people trying to pivot in their careers? Whom does this work for? And this is, the work so far has been supported by 2 NSF grants. And this summer, I'm looking to push for more deployments. So if you've ever been curious about running something like this, I have a easy onboarding checklist for you. And this would be a great time for us to figure out the answer to what works and for whom. And lots of students ready to support. So what's my interest in this? Figuring out generalizable knowledge about how to make online learning work for more people, right? So if that means it improves a product of yours, or it makes good on a promise to try different approaches, I'm happy that it has that service. And eventually, after we have evaluated how well this works, I'm happy for edX to try to eliminate me from the equation, right? How do we get this to work in an automated fashion that doesn't have to talk to research servers, that can do the model training by itself? I have a script that does that. Integrating that into OpenEdX I don't think is too big of a lift. So if you were to replicate this, this is exactly what you would need, right? So when I'm collaborating with Delft in the Netherlands, these are the exact things that I asked them for. After they give me this, we're all set. Okay, there's nothing else. The event log, I give you an example of Software as a Service, Armando Fox's event log file name, for a previous offering, and then the course XML files from that previous offering, the course XML files from the current deployment course. See, that says 2018, the others say 2017, and then to copy an HTML and JavaScript snippet into every page of the deployment course. And that's all. And then we stand up the machine learning web service, and you're good to go. So this was done on edX.org because no code was required to be checked in order for this to work. Again, I'd be happy for edX engineering to figure out how to support things like this, so it's more automated, but no code check-in required here. If you want some extra analytics about what learners in your class are mastering and not mastering, there's an extra requirement at the bottom that a taxonomist label pages with skills, but not required for what you've seen so far. If you're wondering, have you done your due diligence with IRB? This is human subjects research, right? I have. There you go. There is the IRB approval received on May 16th of this year. Because the previous studies were just to test if the engineering would hold up, right? We really deployed it, but we didn't look at any outcomes because the humans were not the subjects. The whole framework was the subject. But now we want to pay attention to the humans. And this is approval for multi-site experimentation. So if you're interested in partnering, adding your site to this IRB approval is relatively painless to the time it took for this one to be approved. So I'm going to show you how we've applied a similar idea to on-campus. Okay, the same idea of collaborative-based personalization, which means what can you utilize out of the data you've collected about learner behaviors, learner selections, to benefit other learners. And this is beta. On campus certainly needs a lot of attention in this area of, now instead of within course recommendation, across course recommendation. We know advisor ratio is 1 to 400, and that's at the top schools. It's more like 1 to 1,000 at community colleges. Course catalogs are mainly 1.0 web experience, so there's a lot of room for improvement there, and about a 50% graduation rate if all of that wasn't good enough for you over 6 years, meaning when the student starts their bachelor's program, 6 years later, only 50% have earned that degree. And in spite of California being an incredible upward mobility machine, only 16% of community colleges earned that bachelor's degree after 6 years of starting at the community college. And Pathways is part of that, I would say. So in collaboration with the UC Berkeley registrar, who now links to our website on their course catalog, we call it Ask Aoqui. Aoqui is the mascot of UC Berkeley sports teams. We can provide, we are providing, it's live, information like this. For your major, sorry this is low, small font, given your course history and major, and you would specify it here, these are course considerations. We don't say suggestions anymore, we say considerations. For spring 18, so this is cross-referenced with the course catalog, what's offered in spring 18, and what students who had a similar course background to you had, what they took for you to consider what you might want to think about. And that's kind of normative, right? It's not what an advisor might suggest, but many students, particularly first-generation college students, don't have a social network to know what the normative thing is. So since we are collecting enrollment logs, we might as well surface it to students as another informational source. You can be a double major. You can specify filters like, I only want to see economics courses, and I want you to sort these courses by those most relevant to public policy and not so relevant to statistics. So if you want to take an economics course, but you want to avoid calculus, you may not be able to figure that out by reading the descriptions of some instructors' courses, but our machine learning figures that out in some cases to a better degree than their description gives. We've looked at how well we're able to predict what the student was going to register for in terms of courses based on how many semesters they've been at the school. So how many semesters worth of data do we have? Recall just means what percentage of, on average, the 5 or 6 courses that they take we are able to predict correctly. So at the peak, we're almost able to predict half of those courses. And that's after 2 semesters at the school. And that's right around when a student declares a major and perhaps their course selection becomes a little bit more constrained. These other lines, this is if you always, the blue is if you always predict the average courses, like the most popular courses. And then the green is if you pick the most popular courses by major. So there's a lot of signal that's being learned in the personalized recommendation based on your history on top of what you might suggest as the most popular thing. The kind of theme that I want to touch on that's larger than the things I've been talking about is this idea of when applying AI to education, these are the 3 categories I like to think of in which you can apply AI, or the ways in which you can apply it. And I'm, of course, using an analogy of the road here, where you can provide information to the learner. An example of that course recommendation, they could select, I only want to see economics, and then I want to sort that by something. It's sort of information retrieval. It's more like a query. So you're providing information to the learner there, versus a GPS, which is that next step recommendation servers, where you're suggesting what a student might want to do next. And then there's this idea of full automation, which you only really see in education when it comes to computer adaptive testing, picking the next item in order to assess you more quickly. Otherwise, full automation doesn't really make sense, right? You always want the learner to know, to be reminded that they're in charge of their own learning, that you're there to support them, but let's never give them the idea that an AI is going to learn for them, right? So we have to be very careful in how we market the use of AI to students to not give them the wrong mindset to start with. For hearing more about how to get involved with these adaptive tests, please email me. Or if you want to get right down to business, my calendar is right here, tiny.cc/zpUCB. And you can just go ahead and send me a cold calendar invite, 30, 40-minute slot. I'm free most of next week for these kind of meetings. So please get in touch that way, and we'll exchange niceties at the beginning of the Hangout. There's a couple other adaptive interventions that I've referenced in my profile page. One is being able to target emails to users based on their engagement analytics, such as if a learner is a high probability of completing the course but low probability of passing the course. You can target just those learners based on daily generated analytics, and I'd be happy to talk more about that in a follow-up session. Thank you.
Thank you so much, Zach. That was a very interesting talk. We have several minutes left for questions. If you have a question, please raise your hand. I'll give you the microphone. These sessions are being streamed live. Please quickly introduce yourself and ask the question. Thank you.
Hi, my name is Monica Diaz. I'm from Stanford University. I work with instructors. I handle support. So my question is just, you mentioned a course in which you used this, Introduction to Aeronautics Engineering. I just wanted to see it. So is that something we can access?
It's closed now. It was in early 2017 that we ran the course. I'd be happy to show you a demo and stand it back up. But yeah, no, it's not open anymore.
That sounds good.
Oh, actually, it's running in a course right now. So if you get in touch later, I can send you a link
Perfect.
to where we're running another pilot.
Thank you.
It's another Delft course.
Thank you. One of you had your questions first. First and then.
Hi, I'm Lauren Milliken, MIT, and I was wondering for training the neural network, approximately how many active users do you think you would need for the previous course? Or the previous offering?
The smallest amount that we've seen a predictive signal with has been 600.
600, okay.
Less than that doesn't work very well.
Yeah, that's what I would figure.
And for the course that we did run is 10,000 enrolled, but more like 2,200 certified, and that's who we trained on for one revision of it.
Okay.
So that's on average, I guess.
Yeah. Thank you.
Sure.
Hi, my name is Valérie Psyché. I work at TELUC University in Montreal. You made some prediction based of behavioral diagnostic of the learner. Have you thought about using epistemic diagnostic? Like not only only behavioral, but the epistemic diagnostic of the learner.
Is there a good established test for epistemic cognition? Or what would be a good survey to collect epistemic information?
In order to give a prediction about the next page or the next page it will take on the next course, it would be interesting to know maybe how it performed in this first page, not just the video that it watched, or you know, like
so
combining not just behavioral but as well the way it performed.
Yeah, okay, thanks. So the performance.
Yes.
Yes, that's very true. In this version, we ignored performance. It's sort of the complement of computer adaptive testing. We're ignoring all the assessment information and only looking at behaviors. In the current pilot, we do include the history of if you answered a question correct or incorrect, along with the history of your behaviors. That's a good suggestion.
Thank you. That was a very good question. There was a question on this side of the room.
And in that part of the slide that I flashed, and I'll upload this slide deck to the edX Conference Manager system, that extra column that said if you want mastery analytics along with these recommendations, that's definitely looking at how you answered problems, as well as what you looked at in terms of behaviors. So if watching a video a certain way was correlated with certain performance, it could even assess that mastery or would attempt to estimate that mastery even with sparse problem answers.
Well, Bruno Podubert, Université de Montréal, School of Education. So I have two questions. First question is, what kind of effects do you expect on learners? I have a hypothesis, but I'll let you answer.
Do you want to start with your hypothesis?
Well, would you look at student engagement, like more engagement, less time to complete, more persistence? Are these your hypotheses?
Yes, so exactly those. For the pilot we're running right now, something as simple as what percentage of the learners in the experiment condition persisted on to the next chapter, right? What percentage earned passed the course versus didn't pass the course, and maybe the third one, which is a little nuanced to our efficiency hypothesis, is perhaps none of those things increase. Maybe certification doesn't increase, maybe persistence doesn't increase, but since we're making this hypothesis about efficiency, given those things stay stable and don't drop, that would be a tragedy. That would be bad. Do they save on time on task, right? Is there less time on task for the same outcomes, or the same time on task for better outcomes? That would be a hit for us.
Okay, thank you. Second question. Do your mastery analysis framework apply in another language, for example, French?
Absolutely. Cognition is language blind, race blind. Yeah, all of the training for this, those files that I mentioned, everything is just tokenized, right? Everything is an index to represent this question, an index to represent this page. So in terms of all of our scripting that we've done to operationalize this, there's no localization required in terms of language. And I'd be very interested to see how it performed in a language outside of English.
Brian Moore from Ivado. Very interesting use of RNN for this kind of application. I have a question about recommender systems. Sometimes they have an aspect of exploration. So you analyze the path of student going from one page to the other. How would you see that? Do you think there's a possibility of exploring new link between the content, or in this context, how you see it?
Yeah, great question. So there is something called filter bubbles in collaborative filtering, recommenders based on data, which is a recommender system. Let's say a YouTube recommender could kind of start to stereotype you and only recommend certain types of material for you, which could be not beneficial to exploring the space. To get over filter bubbles, there's a couple things you can do. One, you can let the explicit preference of the user dominate. So in the case of the course recommendation system, the user can turn off the collaborative filtering and just specify subject interest and disinterest, right? And so they've totally defeated the collaborative bias, and now they're essentially submitting a query, right? So that's one way. Another way is to deliberately insert serendipitous recommendations, right? Not just this is what other people did, but now let's throw into the mix a second recommendation. You don't always have to recommend just one thing, right? Google recommends 10 on one page. Insert a recommendation that's based on kind of a diversity metric. And that's something we're pursuing in the on-campus course recommendation.
Thank you. Are there any other questions? If the audience doesn't have questions, I'm going to make up some questions. We have, yay.
Thanks. Jeremy Osborne from Aoqui Gymnasium. So I guess I have a question about the course design. Since it assumes a second run of the course, to what degree is the instructor involved with that? And who do you see kind of owning that process, looking forward? Is the instructor a big part of that, or how does that work?
In terms of the logistics, the instructor has not been involved in our pilots. I mean, they've approved, but they've not been involved in any decision-making after approving. Mm-hmm.
Okay.
Yeah, I have a follow-up thought. It's maybe not directly related to that, but there is a kind of framing question, and maybe a psychological question I have for the recommendation, which is, or the perception of the recommendation. Do learners perceive this recommendation as coming from the instructor, right? Do they see it as an augmentation of the courseware and sort of aligned or oriented with what the instructor is trying to get across? Or is it a personal assistant of theirs, that's trying to help them in their prerogatives, whether their prerogative is just to get a certificate and not learn anything? And I think that's an interesting question, and it's also something we've had to reconcile at the university level. Should this recommender really just serve the interests of students without any kind of pedagogical oversight? The answer has been no. If we're just up to the students, or if we're up to a large majority of students, the system would be predicting the grade that they would be getting in courses, and they would be selecting courses based on that to keep up their GPA. You could say it's my own pedagogical influence to say, nope, this will not be your personal assistant to do that. But if you go all the way and you say, we're going to use data to help students do whatever they want, that would be what they would use it for, or one of the things.
Right. I guess my follow-up to that would be, so usually there's a linear structure that an instructional designer will think of. And so this kind of, to me, feels like it would add a non-linear aspect, jumping from section to section. And I guess I'm wondering how that affects the student's experience to all of a sudden kind of break the chain of thinking from the instructor's perspective to say, go to this page or watch this video, or does that make sense?
Yeah, that makes a lot of sense. So I think it's a matter of framing also, where if we're saying it's recommended and they assume it's recommended by the instructor, it may break that cohesive linearity, which is why we're also thinking about presenting it as a kind of review suggestion. Like, you are weak in this skill, you may want to think about reviewing it, because then it's based on some evidence of cognitive mastery, and if it is their prerogative to want to earn a good grade, then you're being a little bit more directed about their learning. So that's the alternative if their sensitivity is about breaking that intended structure.
Thank you. It was also very interesting questions, and I think there might be a couple of questions, but we're actually at time for this room. And you may find Zach afterwards, or
yeah,
roaming
I'll be
around.
right here,
Yes.
getting coffee.
Thank you.
Thank you.
Thanks all. Mhm.